live? Awesome. Okay, let's get started. Hi, everyone. Welcome to episode 3 of the White Van Podcast. Today we have some interesting topics and awesome guests. This is our first time doing a video stream. As always, feel free to leave comments in the Twitch box and we will try to get to them. And also shout out to Jerry for hosting the stream and John for editing. So starting off with introductions. I think we can go in the order that we appear on the screen.
Krish, that's you first.
Okay, cool. Hi everyone, my name's Krish. I am going into my hopefully last year of school at UFT. Not that I didn't like it. I love UFT, but excited to be almost done. I'm currently working as a software engineer at Red Hat, where I do R&D work under the office of the CTO. Who's next? Mike?
To me. Hi everyone, my name is Michael Liut. I'm a assistant professor teaching stream at the University of Toronto, Mississauga. I'm a computer science professor, so that's my field of discipline.
Hi everyone, I'm your host, Orange. It's all about me.
And I am Blossom, so Naz. I'm a third year University of Toronto, Mississauga student, currently doing PY as a DevOps intern at Oracle. Lucas.
Hi. Yeah, it's me. Hi, I'm Lucas. I'm entering my final year at UTM. I'm currently finishing my PY. I work as a GPU virtualization intern, I guess, at AMD. Yeah, that's it.
Hey, that's everybody. So to start off, we have a carryover question from the previous episode. So last week's guests wanted to ask you guys, for the student guests, what's one thing you wish you knew before coming to UTM? And then for Mike, our professor, the question instead is, what was it like doing all of your studies at McMaster? And what's one way that U of T has been different? So again, we can go in like the order that we appear.
Sure. So I guess one thing I knew before coming to UTM, I guess the obvious thing is like post, right? Because most people haven't heard of that before they start here. I know for me, I didn't know about it until halfway through second semester. And so there's a little bit of panic there, but managed to pull through. And so that's one thing that I would definitely recommend first years, look into or learn of before they enter, not just UTM, but any of the, University of Toronto schools. Mike?
Sorry. So Mac was, Mac's short for McMaster, for all of you who don't know. But I really liked it. I enjoyed the school. I actually never thought I'd stay to finish my master's nor my PhD. I was totally gung-ho about getting out of there after my 4th year of undergrad. But the university itself was really nice. The area around the campus was, as we coined it, the student ghetto. It was okay, but as I sort of developed more time there, you realize that McMaster or Hamilton isn't just the university and its surrounding space. It's a lot bigger than that. One thing that sort of has made U of T a little bit different, and sort of what drew me to U of T specifically, so my similarity first is that Mac and UTM specifically have a very similar community in terms of being student-oriented, focused, very, supporting of one another, which I really, really liked, and that drew me to the faculty, or the university specifically. But you guys have dedicated teaching faculty, and that's something I never had coming from the Faculty of Engineering. The teaching stream folks here are awesome. It's a very drastically different experience because McMaster, similar to St. George, is a very research-focused location or campus. UTM is still research focused, but they do have way more in terms of events, gatherings, and just sort of social things that happen for students. Now, given that we have robotics in CS, it will eventually grow and be very similar in that aspect, but that's sort of the one big thing I noticed that's different.
Yeah, so for me, the one thing that I wish that I knew before coming to UTM, like Chris said, is knowing about posts. And the other thing is knowing about more resources to, get connected with students. For instance, I actually didn't know much about Discord until like my second semester, first year, and that really helped me, in terms of like getting questions to ask instructors and knowing that everything's all right and I'm not the only one going through this, getting friends in general, because I think people in CS connect lesser in person than they do online.
Yeah, I agree. It's really easy to get trapped in like a loop of just like, focusing on, class or internships or whatever you're interested in and forgetting that, university is also, a social experience, right?
Yeah, from my side, it would have been post, surprisingly, and knowing what CS actually is, because going in, you think, oh, I just type and something comes up and my program works, but there's more to CS. You need to learn runtimes, program correctness, all of the theory behind it as well. So definitely learning more about what CS is would have been helpful for first year.
Right. So for everyone listening in, definitely keep those in mind. Useful things that we wish we knew before coming to UTM, and maybe you can know that in advance. Okay, so now we're moving into the core of our podcast episode. This week's topic is about futuristic technology. So we're going to go over, is it all hype? I'll read some common buzzwords that you hear about and discuss whether or not it's all just hype. And we can go through things like applications, growth potential, paths if students want to study this area or this field, etc. So starting off, cloud computing. A quick definition of cloud computing: it's the practice of using a network of remote servers hosted on the internet to store, manage, and process data instead of using a local server or a personal computer. So going off that definition, what do we think about cloud computing? Anything to add?
I'd say it's pretty important. It's my job right now, technically.
Same.
But yeah. Oh yeah, Chris, you're the power you can leverage using cloud computing is something you can't get within a local system, for example. Because my brother is doing his master's and he needs a 1080 Ti. But using my work, we could in theory split a 1080 Ti into multiple GPUs that other people can use. So the amount of hardware that you can leverage using cloud computing is very important. And then there's also the problems of networking. You can use cloud computing, they'll handle the networking for you if you want to host a website.
Mhm.
Right?
Yeah, I agree.
It's super neat because you as like an end user don't have to bear the entire cost of the hardware. So you can say, oh, I need it for this like small project, and this small project ends up costing you, I don't know, like $10, whereas the hardware could have cost you hundreds. So that's sort of a neat thing. The other really big thing too is that you can scale applications quickly and sort of on demand. So if all of a sudden your server reaches a peak, well, I can spin up 2, 3, 4, 5 instances across the world that best serves my needs, which is really, really cool.
Yeah.
So it's definitely not all hype. It's pretty awesome tech.
Yeah. I would safely say cloud computing is not hype. I mean,
Yeah.
for me, a lot of my work is like prototyping and stuff like that. So it's kind of magical, being able to spin up like this really powerful server on AWS and use that. And then, when I'm done, spin it down, right? I don't have to go to any team for hardware or resources or anything, right? And it costs my team like what, $5-10 maybe max. So it's
Yeah.
crazy. It's such a big like paradigm shift, right? In how we look at deployment and infrastructure.
The one thing I wanted to talk about related to cloud computing was like, in cloud computing, you hear so many buzzwords like AWS, Azure, Google Cloud, and then I think Kimchi was pointing out IBM. So there's so many companies that are coming into cloud, and then they have their own certifications. Other than that, in the technology, you have different ways of doing stuff, like Kubernetes got really popular recently. People are rushing to learn Docker. There's just so many words for students to process and know about before they graduate. And the reason I find it kind of interesting is that, there's all this technology to learn right now, but a lot of it isn't really taught in courses, undergrad courses. So if we were to talk about, just starting with something like certifications, do you think there's some certifications that are more important for students than the others, like learning AWS versus Google Cloud, or like, would you give something more preference?
What I can comment on is, from what I've seen, Azure is clawing its way to become one of the forefront leaders in cloud computing. So it's definitely not a bad idea. And then the capabilities of Azure itself, excluding stuff that I've heard of. I attended a conference once for Azure, and it's talking about auto load balancing and automatic Kubernetes setup. So there's definitely lots of things for Azure that you can use that would make it an ideal candidate to learn above the rest.
Yeah, my personal 2 cents as like somebody who went and did like the Azure cert and like the Google GCP cert is like, I would say like I wouldn't do it just for the certification, right? Like I don't think you learn enough for it to be that valuable as a certification, right? Because like 90% of the time they'll make you like answer some questions about like, what is this concept, and then you'll spin up a VM and then you'll spin it down, and that's like the certification. And so like that by itself, I don't think adds that much value. But the real like value for me is like once you learn the concepts in Azure or GCP or AWS, the concepts pretty much translate over to one of the other platforms, like 90% similarity, right? The terms will be different, right? Amazon has S3 and Azure has blob storage, and Google has their own object store, and so their names are different, right? And that can be confusing to like a new developer, but the concepts are pretty much the same, at least in my experience.
One thing to be said there too is that with your computer science knowledge and background, you have a lot easier time distinguishing the difference theoretically behind why I use a container versus why I use a virtual machine, what the difference is between them. And that's something that can carry over regardless of the term. So if we're working with like Azure's platform, or if we're working with like a Amazon like EC2 instance, for example, it doesn't make it, like you said, it doesn't make a difference. So I definitely do agree with you. As long as you can understand how to take the ideas, take the same concepts and roll them into another platform, that's really all you need to be successful.
Mm-hmm. Just to add on to that, something that you mentioned, Nas, was like it's really confusing for like students and stuff because they don't know where to start because there's so many buzzwords. Like my approach to like for learning like this whole like deployment and cloud and Kubernetes ecosystem was like to learn to look at it like historically, right? Like why do we need containers, and why is it better than VMs, right? And what was the predecessor to VMs? Like why are we moving towards Kubernetes and towards cloud as opposed to what we had before, right? Why can't every company just buy a bunch of servers and use those? And so looking at it historically and seeing the progression, I think is really useful, because then you can also express the value of these new technologies, right? You can't just like parrot off the buzzwords.
Right.
Right.
And I think the one thing that gets confusing is because when you want to learn about these technologies, it's harder to learn them, I think, than like the other stuff that we learn in undergrad CS, because you think that you need to get all these VMs and then start your own app and then deploy it in like a cloud environment and then actually test something out. So is there something you would recommend for students to get started other than just like jumping into companies and, having to do it hands-on directly, because it's harder to learn on your own?
Well, I know from my experience with Memorable, the best experience I got was doing it myself because that's how I learned how to mess up, what the solutions to the mistakes were, and then the steps to go through that. So we went through DigitalOcean, for example, and there were lots of quirks that you needed to learn about. And then further into the actual deployment of something, it's all something you make mistakes and learn from. I think that's unfortunately the best way to learn, is to make the mistakes that you don't know about.
A lot of people also don't.
DigitalOcean. Oh, sorry. Go on.
Oh no! All I was going to say was a lot of people don't know that GitHub has a developer account where you can sign up as a student and get a ton of these services and these classes for free, and that's a huge benefit. Just going on there and scrolling through their like 300 plus options of free things like the Azure credits or the Amazon credits, and just going there and playing with it.
Yeah. Like that was something that was intimidating for me, was like it seemed like cost prohibitive, right? You hear the nightmare stories of someone racking up like $1,000 bill on like EC2, like they spun up this huge server and they just left it online and they forgot about it. But the benefit of like all these programs is they give you like, hundreds of dollars worth of free credits that you can use to just play around and learn, right? I think basically every provider, minus GCP has one, but it's kind of stingy, but Azure's and AWS is like pretty good. So I would definitely recommend looking into that for anybody curious about cloud.
Yes, definitely check out the GitHub pack.
And then transitioning a bit from these to like databases too, I want to do that right now because we have Michael with us, who's like a databases expert too. So I know that I think AWS promotes NoSQL databases a little more than SQL databases, which is something that I think Azure specializes a little more in, because they have the SQL server and everything. So in terms of just databases, if students are just getting started with databases, would you recommend that they start with SQL first, or?
It's sort of a hard question because you need some sort of fundamental basis. And we're always taught structure is best, so let's work with structure, which is why you see, for example, courses like 343 or their equivalents teaching like an intro to computer science, an intro to database course. They all sort of cover the same thing. It's just sort of a stepping stone into the field. So when I think of it, I think of a tamed version of like 148, for example. In terms of like the difference between learning NoSQL or SQL, in my opinion, it doesn't really make much of a difference. The one thing that will make a difference is if you teach yourself how SQL works incorrectly. Because in your mind, this is a way that a structured query language should operate in, and this is the way in which I should be grabbing information without any understanding of the design philosophies that exist behind the scenes. It's going to cause a problem because you don't fundamentally understand how to design the database or why it's being designed in a certain way. And it sort of shifts to like tons and tons of different things. And really right now in industry, there's tons of problems that exist within like speed and scalability. And not just in a relational database, in a non-relational database too. Oh, that and replication, but we can chat about that later.
I'd just like to comment. I hate SQL. So
Yeah, same.
I think you learn NoSQL, but that's
I think SQL is valuable, right? But it shouldn't be like NoSQL, SQL. They both have like their valid use cases.
Yeah.
And you always gotta pick the right tool for their job, right?
Yeah, that's fair.
Mm-hmm. But like
why do you hate SQL?
I don't know. it just feels so archaic. You just do select something from something dot 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 dot, and you can get such complicated queries. Whereas with NoSQL, you can just do one generic query, and then you can parse it better, from my experience.
Yeah.
And I'm also guessing that when SQL is deployed in actual production, from my experience, it got very messy because you patchwork so many things because this query fails, for example, but then this one works.
Mm-hmm.
So you patchwork that first query, and then this breaks. But
that all stems from poor design. It just means that the people who designed the original database didn't take a good introductory course.
Yeah. I'm not.
I think
Hey, I took 343 downtown, so I can't,
No, I see that a lot, and that's sort of a big point of contention. A lot of people hate the fact that their original database was set up poorly, or that they have to do patchwork, or that a lot of data is duplicated, or that somebody decided to drop the production database without the proper contingencies in place. And we laugh about that, but it's stuff that happens, and it's stuff that shouldn't happen. But that's partially because the people who are in the positions of power, or the people who are controlling this, or who are hired to be the administrators of these databases, don't actually have the proper understanding or expertise. Yeah. With that being said, MongoDB and the push with integration into cloud storage is definitely the way of the future. It just can't be fundamentally what an introduction to database course looks like. Now, an advanced database course, there's an idea.
Ooh, Michael, is this
I agree 100%
with that. An advanced database course at UTM?
It exists. We just don't have enough faculty to teach it at this point. Eventually, hopefully.
After
I agree 100%, Michael. Though, I think SQL is real, just like how we learn C and stuff, and people will complain about learning C. I think it's important to learn that because it's really foundational, and you learn a lot of important lessons that you can then apply to future languages you learn and future projects you work on. I think SQL is the same way, right? You can learn SQL and then you have a solid foundation, right? I think NoSQL is much faster to learn than SQL.
Oh, and it definitely has tons of cool integration.
Yeah.
Sorry,
yes. I think
sorry.
Oh yeah, I was gonna say at a scale, I think SQL is where it gets harder because you have to maintain that ACID model, whereas with NoSQL you can give up a lot of those constraints.
Yeah, but Amazon has a ton of cool stuff right now. I don't know if you guys have heard of Amazon Redshift Spectrum, or anything along the lines of their S3 storage systems. But there's a huge push in this area to store data in their simplistic or raw format, which is very different from how it existed before. So you can actually just query the data right from an S3, a storage instance, and then pull that into something like Redshift, and then have people that actually query the subsets of those databases concurrently. So it's really neat because it integrates two areas, one which we always think of as archaic or really what changes in the database world with cloud computing, and the fact that we can split them up into different subgroups, or what they call shards in NoSQL and MongoDB, and having multi-shard transactions, which are really cool.
And sagas, and I think sagas are really interesting too. But Miss Hermit brought up something interesting in chat. They had a question regarding DynamoDB. Didn't Amazon release their own variation of MongoDB? So isn't that threatening MongoDB's life? I think they're referring to DynamoDB, which is Amazon's version of MongoDB, their NoSQL database. I guess we can talk about that a little bit. From my perspective, I think the way Amazon incentivizes people to use DynamoDB as opposed to Mongo is that they offer it at a lot cheaper price point, but the reason I don't think most enterprise companies will opt for DynamoDB is just vendor lock-in, right? Because if you end up using DynamoDB, you're pretty much stuck in that. And migrating to another provider will be like next to impossible, at least like in a financially responsible way. So that's my 2 cents.
There's also a lot of better
Some-
resources that exist around MongoDB.
And like
Sorry,
a developer
Streamline.
tool system, right?
Yeah.
Something that I saw happening at my workplace was they didn't really trust MongoDB so much because open source, and we had to transition to Redis. So
Because as Microsoft so eloquently put it 20 years ago or something, open source is let's not.
Classic. That quote's never gonna
Classic.
go away, huh?
Yeah, no. I think of it every time when I debug a Microsoft issue.
Isn't Redis open source as well? I think it is, but I think
I
Redis
think it is.
it's definitely more mature, I think, compared to Mongo. And I would say Redis is like more open source than MongoDB, since like MongoDB is primarily supported by the company MongoDB, right? As opposed to Redis, where it's I think almost completely open source. I don't think there is like a primary company that offers support, at least.
Okay, so we have a few more buzzwords that we can kind of zoom through if we're feeling up to it. The second one is microservices. And I'll actually call on Krish to give a definition on this one because he was giving a great definition earlier.
Sure. So microservices is essentially like a design pattern where instead of making, one big application, one giant code base where all your logic is, you separate that out into a lot of smaller applications. And the way that works is that, instead of sharing objects and memory and sharing pointers and stuff like that, with a microservice architecture, you use like some type of communication protocol where where the services can communicate over the network, right? So there's lots of options for like services and how they communicate, like Kafka, RabbitMQ. The list is like endless. But that's the general idea: is that you compose many small services into that one big application. How was that?
I think that's a great
So is it just
definition.
hype? Should students learn it?
I think it's very cool. So I think students should learn it.
Yeah, I think it can bring in lots of important things together because having them separately can. One thing that I've learned in my time at my various positions is stability is important, and having them deployed as microservices will definitely help with stability because you never know when, for example, in one of the projects I'm working on, a random null pointer exception will be thrown, even though you never interact with the part of code that would deal with it. So having that as a separate part, as its own microservice, can definitely help with the stability of things, especially if you can spread your database over in its own microservice. If you can spread it over multiple servers itself, it will help even more than just one single micro server hosting the microservice itself.
Yep, and one thing that this also reminds me of is that I was just talking about Kubernetes when we were talking about cloud computing before, and Kubernetes works really well with microservices because what you can do is, suppose you have some service written in a completely different language, you can deploy that, and that's going to be independent of another language. So there isn't there aren't that many issues with those two being able to work with each other.
Mm-hmm. Yeah,
It's
like
sort of funny. It's sort of funny because microservices sort of transition from like a design principle, the design principle of like low coupling, high cohesion. So that idea that's been a pinnacle software engineering design principle for decades. And microservices is basically that approach, and it's saying, okay, well, we have an approach to an application development, like a large scale application, and it's being built. Essentially, it's being built around like a suite of modular components. So like we have this whole idea of microservices, which is I have this large scale application, and if part of it goes down, it's okay because it doesn't bring the whole thing down. And that's sort of the fancy term for this design principle that's existed for decades. So like in terms of it being all hype, I don't necessarily think it's all hype. It's just funny how they rebranded a term and made it sound like sexier to get people's attention.
I blame the consultants. I think it's easy to like to play devil's advocate. I think there's lots of advantages from microservices, but I think there's like trade-offs as well, right? Like some of the ones that like come to mind is like, if a company is using a different language for each service, right? One is Java, one is C#, one is I don't know, Node.js and Golang, for example. It makes it difficult for people to collaborate and switch between teams, and like there's other issues that pop up where you need to get a lot more like overhead, right? Each request now needs to go over a network, right? And what if there's network failure? And there's a lot of like other things to consider for microservices. So it's not all positives. Is what I mean to say.
Not all sunshine and happiness.
Yeah, unfortunately not.
Yeah, I mean the sunshine and happiness does come back though, because of, like Michael said, the modularity of it. You fire your MongoDB guy, you just hire the SQL guy. It's fine. It's just a module, right? People are expendable.
That's how it works.
Yeah.
Oh no.
Let's not get any ideas, eh?
Okay,
Come on.
so then
It's my
our
job
next
security.
buzzword is oh no, job security.
Oh, no.
So our next buzzword is another really cool thing, AR, VR. So a virtual reality is an interactive computer-generated depiction of a real or artificial world or activity. And on the other hand, augmented reality is a real-world view with additional computer-generated enhancements. So those are our definitions. What should students do if they wanted to study this? Or do you think it's just hype? Does it have like real-world future implications?
It depends on which one and for what. Because AR and VR, they're both, while they have the same general idea, they're very different concepts, because AR is displaying the real world with some form of enhancement in a very basic sense, whereas VR is putting you in a different world. But it also depends, right? Because VR and AR are more used for design of physical things rather than a computer science perspective of it. If you want to work in it, there's, from my understanding, not many opportunities for it. You can join a hardware-based team at, for example, AMD, NVIDIA, and you can work on the driver side, working with AR, VR, where you can get the opportunity to see the latest tech. But if you want to work in terms of the actual VR software, there's much less opportunity.
Yeah, I think a lot of people were like left with a sour taste in their mouth in regards to like AR, VR after like Google Glass, right? Because it was like built up to be this huge game-changing thing, and then it turned out to be kind of a gimmick.
I mean, Google has a history of killing products, so let's not.
But
the possibilities.
The one cool thing about AR specifically is, so like VR is just going to classify that on its own, gaming, cool, maybe videos, but we won't go there. With regards to like AR though, there's tons of stuff in AR, but it's mostly research right now. How to roll it out into, for example, self-driving cars, how to roll it out into robots. How can I perform like precise surgery using certain equipment without actually hitting, for example, the heart wall. There's tons and tons of stuff that exists in that space, and AR in itself is really, really cool. I think right now a lot of the work that's being done or being shown to the public is very gimmicky, but the application in the long term is there. The problem is nobody coming out of their undergraduate degree is going to be able to work in that field. Not to develop the new stuff in that field, maybe to utilize it for whatever. But unless you have like full exposure with an expert in that area, it's going to be way too long before you're going to be able to make any serious impact in that space.
Yeah, I think the potential in the future is the most important thing, because technically when we first got computers, we were doing 1 + 1 = 2, and then we broke the enigma with Alan Turing, and then now we can get these shitty little games to run on our phones that the phones could technically land us on the moon. We've advanced so far, and with the possibility of AR, VR, we can get even further, like designing entire skyscrapers with our hands, just drawing it rather than drawing on paper what it would look like.
Yeah, I agree with Mike that the consumer applications right now are kind of still like gimmicky to an extent, but I do see like a lot of opportunity in the future for like enterprise, for the enterprise side, both like like traditional white collar and like traditional like blue collar work. I think there's a lot of applications. Like if you think about like an engineer could use it to design equipment, and at the same time Amazon has already started working on implementing AR to help people in their warehouses with collecting more packages and stuff.
Yeah.
And however you feel about Amazon, it's still an interesting application of AR.
I'm also like, I know we have an international audience as well, but for the domestic audience, if you've ever traveled in Asia, you'll realize that it's very heavily compacted. And to navigate streets, for example, could be complex. If you're using something like Google Maps, well, you never really know if you're in the exact right location. You don't know where you are. And sort of that second circular grid that gives you, you're in this approximate range, sort of increases depending on the number of phones or signals that exist there, so on and so forth. But one big thing that AR, augmented reality, will come in to play is once you're able to, for example, take photos or use the camera to better direct your exact location. It'll help pinpoint you. So that's definitely another benefit that I could see coming to use more often and more like, or sooner, in terms of like a commercially available product.
So is our TLD that VR is still kind of hype and AR is maybe not hype?
Yeah, I think that's accurate.
Cool.
Yeah, seems like that. So maybe go more into AR. Then our next term is Bitcoin and cryptocurrency. So Bitcoin is digital currency. So new units of currency are generated by the computational solution of mathematical problems. How about this one? If someone is interested in Bitcoin and cryptocurrency, what should they do? Real world applications and stuff.
Other than investing? Because I might have lost some money in the crypto market before, but
it's funny you say that, because investing is more like high stakes gambling and throwing away your readily available cash, because you have no idea what's going to happen.
I think Bitcoin is kind of hype.
Yeah, Bitcoin specifically is hype, but I think cryptocurrency in general.
It's been hype for so long.
Yeah, but I think cryptocurrency in general has a big place in the future. A decentralized banking system, think what you might, but our privacy is important, and the government knowing everything might not be the best thing. And then it also just uses it in terms of having an international standard potentially.
Yeah, I think blockchain, although it wasn't mentioned in like the topic, I think blockchain has a lot of applications. Some that we've started to see already, but just as like a form for like validating authenticity or identity, I think blockchain is super interesting. I know there's some countries that have already started implementing like blockchain for like medical records, which I think is super cool. Like, because medical records are very important. You never want to lose them. You always want to make sure they're valid, because if they're not, you could come into a lot of harm when you go to the doctor. And so like blockchain seems like a great application for that. Mike, I'm interested to get your take because I've heard people like say, blockchain is just a discount SQL database. How do you feel about that?
So I'm going to piggyback off of what you said before that, then I'll answer your question.
Okay.
Right now, so I do agree with what you said with regards to blockchain. It's definitely not hype. There's a lot of great benefits because you have a public transaction log that can never change. You have a ledger that exists that everybody can see. And what's really neat about that is for like verification of things. And you said medical records, but I bet a lot of you didn't know that they're actually doing this for degree verification. It's way simpler to verify somebody's degree using blockchain. So for example, McMaster is actually, their Faculty of Engineering is I believe the first institution in Canada to implement blockchain as a means of verification for their degree. And they're one of the 4 major universities in North America, along with, I think it's MIT, Stanford, and someone else. I cannot remember. There might be a couple more from the States that are on a committee now to determine an international standard to do degree verification, which is really, really cool. But going back to your question about like databases versus ledgers, I think they have different, totally different use cases. I don't think everybody wants every piece of information in a database to become public. I also don't think that it would be feasible to store that. But records, in terms of like stuff you would see on spreadsheets that you may want to anonymize some of it, but keep some of it public, like the actual values in accounts, being able to transfer money internationally, that's huge. But right now, banks use their own blockchain technology to do this verification between them anyway, because each of them can host all like the ledgers on their own system, so they can verify if this was a legitimate transfer, a legitimate deposit or withdrawal.
Yeah, I think that system is called like SWIFT, right? If I remember correctly, like their messaging protocol between banks, internationally at least.
I don't actually know if SWIFT is what uses blockchain, but I know that that's their international standard.
That was really interesting about the degree verification.
Yeah, McMaster's definitely in good company there.
Yep.
Yeah.
Mm-hmm. Okay, then so we have concluded that Bitcoin might be hype, but blockchain isn't, and it's definitely something worth looking into. Our next term is self-driving vehicles. I didn't prepare a definition for this because I'm kind of assuming it's self-explanatory. Self-driving vehicles. Is this term all hype? Do you see the future being filled with self-driving vehicles? And if so, should students how should students go about studying it?
Like this
Well,
as you go first.
Oh no, you can go first.
You sure?
Yep.
So like self-driving vehicles is I just feel bad. I cut you off like 4 times. You're being super nice. Thank you. So yeah, self-driving vehicles hits like 6 or 7 different CS categories. I don't know, like it hits the area of like artificial intelligence and machine learning. It hits the area of like augmented reality. It hits like software engineering. It touches on like safety critical systems. There's probably others that I'm totally omitting here, but I don't even know where to start because it's sort of it's an applied project that utilizes a ton of CS disciplines. Like even graphics falls in there too.
Yeah.
I think self-driving is a big topic. Like it's like when you say someone wants to get into self-driving cars, there's like so many different aspects.
Yeah.
Mm-hmm.
I think it's self-driving vehicles is a bit of too broad of a topic. But to get started and learning about it, definitely you need to learn about ML, AI. You need to learn about systems. Both of my brothers
Robotics?
actually, yeah, both of my brothers
UTM.
coincidentally did some stuff related to this. They learned CUDA because NVIDIA GPUs are all you can use for machine learning. Sorry, AMD. But yeah, there's lots of important things to learn. Systems, especially sensor fusion, but this delves more into the engineering perspective of things rather than a computer science perspective of it.
Yeah, but I think the robotics courses they give you sort of an intro to. Like a lot of the projects that I see students doing are similar to that. And even if you want to check out some research that robotics instructors are doing right now on the ROP app, you'll see some really cool projects there too. So I think that's a good start. And like in terms of hype, I was gonna say I don't think it's a hype, right? Because we've recently had announcements, and I'm not sure if they started already, but we've had announcements from companies like Uber and Lyft, coming with self-driving taxis. That's going to save them a lot of money. They don't need to pay people to drive those cars. And I think even for, things like safety, because you have so many incidents with creepy drivers and whatnot, I think that's definitely going to be something in demand.
Yeah, I agree. I don't think it's hype, but I think the caveat is that I think it's still early. You know what I mean? Like for a couple of years now, Tesla has been saying like, we'll have level 5 self-driving, by next year. Right. And it's like, how many times can you say next year until, maybe it's not actually next year? I think that it's because it's such a like big field and like topic. I think like after like fully self-driving vehicles is still like quite a few years. I'm gonna shoot myself in the foot by saying this because it's gonna come out next month, but I think it's still a couple of years away.
Did you see Tesla's new announcement right after you said that?
Oh no.
And I think Google and Apple have been testing for a long time too.
Yeah, Google with Waymo, I think it is.
Mm-hmm.
Their self-driving division has been going for a very long time.
Alphabet with
the thing is, like, the self-driving cars exist now. It just depends on what degree we want them to function at, and also at what degree will, like, at what level, or sort of like, I don't know what the word is, but like, to what degree, like, these cars have to be made available to the public with certain rules in place. Like, because we still have to go through ethics, they're going to have to go through legislation. By the time we see them available, it may not be 10 till 15 years from now, even though they very well exist and work and function properly. But I don't see like a full-scale rollout happening in under 5 years, that's for sure. So I'm with Krish there.
I think it's like a people problem, right? Like, as long as there's like human drivers on the road, the cars can never be like certain about what's happening.
It's not even that. It's like ethical things too. So for like, they give like extreme cases where if you were in a self-driving car that you've purchased and you're going to get into an accident and there's going to be a fatality guaranteed, do they kill the driver? Do they kill, I don't know, the elderly person who's walking on the street, or do they knock the school bus into the river?
Yeah.
And you look at that and you're like, well, I don't know, what do I pick? But you have different points of view. I bought the car, so I should be protected. Oh, the person is a pedestrian, had the right of way based on the traffic laws in the area, so they should be protected. Oh, you don't want to kill somebody who's younger than you. Like, there's all kinds of things that come into play there. And what do we deem as correct or right?
Yeah, there's the legality and liability aspect too, right? Like, I think there was an accident a couple of years ago where a pedestrian died, and the person was using a Tesla and they were in self-driving mode, and the driver of the vehicle who was unharmed, he ended up suing Tesla because he claimed that it was the autopilot system that was responsible and not him. And so, like, from that liability perspective, I think it'll be interesting to see what happens, because I don't think like the automotive makers really want to take on that additional risk. But right now, they don't have any other option because you can't fully trust the self-driving vehicle, right?
But conceptually, it's totally worth the hype, but in practice, it's more complicated than that.
Yeah.
Seems like our TLDR.
Yeah.
We're
The
nearing
reason.
the end of our episode.
Oh, true.
Sorry,
true,
go
true.
on. Go
Never
ahead.
mind. No, never mind.
Okay, so we're nearing the end of our episode. So just to wrap up, we have a question for each person, which is, what kind of technology is each person interested in working on and why? It doesn't have to be one of the technologies that we mentioned in this episode. It can be anything, but just what are you interested in working on in this field of technology? Go the same order, like in the video.
That's you, Krish.
Let's go backwards. Lucas, you start.
Oh yeah, sure. Why not? Cool.
Passing the buck.
Yeah, sure. Well, given my current job, I think cloud computing is very interesting. The possibility of having a powerful GPU on something that you pay $1 for example, is definitely something interesting. So that's one place I would want to go. But in a different vein, or I guess it's still, I want to go into cloud computing mainly because that seems like a very definite place where I can achieve lots of my goals. I know cloud computing is a very broad thing, but I think going into something with scalable systems, probably working in the back end of Azure or Google Cloud, something that would be very interesting to go into, despite how broad it sounds.
Guaranteed money.
Hey man, I just need to get that Cali position, all right?
Yeah, with me, I'm also interested in cloud computing because I think it is going to be widely used whenever you have a large audience. But a little more than that, I'm interested in AI and ML specifically because after we've had this pandemic, the demand for online education is rising even more. And I'm personally, a big advocate for self-paced learning. So something that I'm interested in is seeing how we can use AI and ML to, provide self-paced learning to students in a better manner. I definitely think that that's something worth looking into.
Yeah, I'm definitely an algorithms guy. So, there's sort of two folds here. One is sort of a continuation from my dissertation, which dealt with like pattern repetition and pattern recognition. So, basically along the lines of like combinatorics on words or in the space of algorithms on strings. That was a lot of fun for me, but I also really like AR, and I've been doing a lot of cool stuff with augmented reality using like indoor localization. So how exactly do you pinpoint your location inside of a building because GPS loses accuracy? How, if you're in the middle of a busy city like Tokyo, for example, with tons and tons of side streets, how do you pinpoint exactly where you are if, for example, Google Maps doesn't function properly? So I've been I've been spending a lot of time in and looking a lot into those areas. I think that they're definitely cool ways forward in terms of tech.
Yeah. For me, my work right now is really focused on like Kubernetes and distributed systems. So I think that's something that I really want to focus and learn more about, just because it's like such a big ecosystem at this point. But I'm also really interested in like RPA, which isn't really something that we talked about, but the concept of RPA is just like automating an automation at a scale, like for enterprise. Feel free to look it up, or I can answer any questions in Discord or Twitch chat after. But I think that is also a super interesting and high growth area. Orange, I'm curious to hear from you. What are you interested in?
For me, well, I'm
Yeah,
interested in
turning it around.
things. Still some more research to do, but I find AR and VR really interesting, specifically in terms of like how it can be used for simulations. I saw this awesome application where people were using AR glasses to practice presentations, and then you just develop skills, and that's like, it seemed like a very real world application that you could imagine yourself using. So I think more applications like that would be interesting in artificial reality? Thanks for asking, Krish. All right, so that is the end of our episode. And as you can see, technology is really cool. Lots of potential for the future. Thank you to all the guests for that awesome discussion. And to wrap things up, I'd like all of you guys next week's mystery guests to answer at the beginning of their episode. And it seems like we are revealing next week's mystery guests already. So next week we have the topic of internships, and our professor is Professor Iliardima, and we're really excited to speak with him about that too. All right, guys, so come up with a question for next week's guest to answer.
Next Friday.
Yeah. What's the worst job you've had?
I'm on
What's the worst job you've had?
no.
You're gonna get fired.
Okay. Worst project, more general.
Project or worst course you've ever had to teach?
Oh yeah, same. And why were the students? Ilir came in, kicked Lukasz out.
Yeah, what? No, bro. Are you really trying to get Ilir fired now?
Tune in next week to hear those answers. Bye, guys.
Cool.
Does everyone like that question? Want a different one?
You want to say it again because I disconnected?
Oh, the question was just like, what is the worst project you've had and why? And for Ilir, what is the worst course you've had to teach? Maybe not that one. We'll see.
And why?
Okay.
You can quote my name in giving that question.
All right, I'll be sure to mention that it was you.
Michael's idea.
Oh yeah, also, if there are any questions in the chat, please type them now. You can take a look at it.
Mm-hmm.
Please send for us.
Yep.
I'm not going to lie, I was hoping you'd ask me if AI was all hype, because I had a perfectly round up answer for yes.
That's one of the questions we skipped.
Is it all hype, Mike?
Yeah.
Is it all hype? We can ask it now. I'm curious.
AI is all hype.
Yeah. Machine learning bad.
Say it after I based my answer with it.
Only nerds go into artificial intelligence.
It's true.
The real chats go into cloud.
Why is AI all hype?
AI is not hype from a technical perspective. It's just every other discipline that decides that they want to use AI. So, for example, you have a master's of management in artificial intelligence. That doesn't make sense.
Yeah.
I have no idea what you could possibly teach in that area.
This is how you make sure your developers develop an AI.
I still blame the consultants for that one.
No, it's
There's
funny
also
because
Go on.
there's also the heck. Oh, I was just gonna no. Naz, it's your turn. What were you saying?
No. You were talking first.
All I was saying was it's funny because U of T doesn't call it a master of AI, they call it a master of management analytics. And Western has named it properly too, but then you have Queens that comes out and it's a master of management in artificial intelligence. But that's they just picked the hype word. I don't know, I want my cereal with a side of AI. Can AI pour my cereal?
Soon.
Yeah, there's still people using if statements and then saying they're using AI or ML.
AI is just if statements.
using the
You can't change
buzzwords.
my mind.
Yeah.
Michael, we have a question for you from the chat, which is, how do you stay
Sure.
so motivated during the pandemic?
How do I stay so motivated? That is an excellent question. Honestly, I binge a lot of TV and I work a ton, but when it comes to television series, my brother and I seem to watch hours and hours on end. So if any of you guys out there are doing this too, that is definitely a motivating factor. Yeah, that and
What
I like
series?
Oh, I'm rewatching Breaking Bad.
Good choice.
Yeah, I just finished rewatching all of House.
Also a good choice.
Yeah, the classics.
Yeah, those are sort of the ones I'm going through now. But like, I can polish off an entire season like that in like a week, which is really bad.
It's a skill.
Yeah.
It's a skill.
Take notes, guys. That's how you stay motivated.
I'm gonna add that to my resume now.
Yeah, I can
We
watch
have a question
Netflix.
from Mist Hermit, which is, what are great places to self-study compilers?
Sorry,
That's
to
for
what
you,
with
Mike.
compilers?
To self-study
Question
compilers.
is, what are some great places self-study compilers?
That's sort of hard. There's not there's the traditional Dragon book that exists, which everybody who's ever touched compilers has probably seen. That's sort of the traditional book to start with. I don't actually like it. Fundamentally, it's good. I don't actually think it's a great starting point. But there's not really many resources that I can name off the top of my head that exist within that space that are easily accessible. But I would use the guidelines, like the table of contents section from the compiler book, and sort of fish from there, and then investigate other areas, like those areas in depth outside of just that book.
There's this one question that I'm really interested in from Phoenix Garuda. He's asking if you're hyped for 108.
Am I hyped? I'm hyped for 108. Everybody knows I'm in TA scheduling mode right now, and that has been an absolute delight. No, I am. I'm excited. It's going to be totally online. You're going to come to my
absolute
virtual
nightmare.
No. It's like, I don't know. I'm super excited. It's going to be totally online, but it should be a lot of fun. There's a lot of stuff that I'm trying that's going to be new, which will also be fun. Maybe just for me, but I will have a good time doing it. And my smile should give you guys a smile, you know. This is just a 108 student. Sorry.
I'm excited for 108 too.
We have one last question, which is, when is your book being published, and what book topic is it? From Innocent.
Excellent question. I don't know who that is, but they must talk to me. I do. It's a compiler textbook. It is.
Ooh.
Okay, so I had a draft pretty much fully written that I'm going through again because I want to make it nice and neat. I'm about 5-ish chapters into that. So I was aiming for November, but that at this point looks a little bit too optimistic. Maybe November of 2021. Yeah, that's sort of my goal. I wanted it ready for the compiler course this year, but I don't think I will have the entire draft done.
Maybe
Can I get
ebook?
it autographed if I buy it?
Yeah, same.
I will give you an autograph, yes.
Yeah, me too.
Yes.
Perfect.
Is it like collecting Pokemon cards?
Happy customers.
Is this just going to turn into Pokemon cards? Because like we need to get Dan to sign his book too, right?
This is true.
All the signatures.
Yeah. We need to get each prof's book, get them to sign it, and then this is a UTM collection. Ultimate
I thought you were going to say we'll sell it later.
Oh, no, dude, are you kidding me? No.
Autographed
No, you
book.
gotta save. You'll sell it in 30 years, you know?
Yeah, that's true. All right.
When Michael's famous, we can sell it.
So it seems like we've gone through all of our questions, which is awesome. So bye, guys. See you next week.
Thank you, Michael, for coming on this week.
Welcome.
Yeah, thank
Bye,
you.
everyone.
Bye, everyone.
Bye.